This next wee clip is to look at resistance in both series and parallel circuits. I've actually got the multimeter in front of me set to measure resistance. Right, they can actually be used as what they call an ohmmeter, which would just be a circle with the ohm symbol inside it to show it's just measuring resistance. You can see on the screen here I'm getting about 10.1 ohms, and if I hold up the resistor here, you can actually see it's marked as being a 10 ohm resistor, so it's pretty precise. I can do the same with a 15 ohm resistor, and you can see it's probably a bit less accurate. Okay, it's giving me 15.6 ohms when I should only be hoping for 15. And the last resistor I'm going to use for any one of these circuits is an 18 ohm resistor. And again, you can see it's quite precise. That's giving me 18.1. I've now connected the 10 ohm and the 15 ohm resistor in series with each other. And if you look at the reading on the ohmmeter, you can actually see it's quite simply the two numbers added together. If you remember, the 15 ohm was actually really reading somewhere about 15.6. So 10 plus 15 would give me 25. I've now added in the 18 ohm resistor, again in series, and if you look at the reading on the ohmmeter, you can see it is essentially just 18 ohms more than we had for the 10 and 15 added together, because 10 plus 15 plus 18 would give me 43 ohms. So for a series circuit, to get the total resistance in the circuit, we simply add up all the individual resistances of the components in the circuit. I've now back to just the 10 and the 15, but what I've got them now, I've actually got them connected in parallel. So I'm just going from end to end here on them. Now, if you look at the reading on the ohmmeter this time, it's not 10 plus 15, it's actually just about 7. Now, in a parallel circuit, the overall resistance is always less than the single smallest branch resistance. So in this case, the smallest resistor I've got is a 10 ohm resistor, so overall has to be less than 10, and it would suggest that's the case here. I've now added the 18 ohm resistor in parallel with the 10 and the 15, and again we can see that the resistance has actually dropped, because the more resistors I put in parallel with each other, then the lower and lower the resistance is actually going to become. Quick check again, the smallest one was a 10, right, and this value is certainly less than 10. I'm just going to finish off with one special case here. What I've done now is I've now connected two 10 ohm resistors in parallel with each other. And if you look at the screen, I'm getting just about 5, right, 5.2. If I had two resistors in parallel, the overall resistance is simply half of one of them. So a half of 10 is 5. If I was to put another 10 ohm resistor in here, I would expect the reading to be somewhere around just over 3, because 10 divided by 3 would be 3.3. If I was to put a fourth 10 ohm resistor in, I would expect it to be 2.5. Again, you would see the more and more I put in, the less and less the overall resistance becomes in a parallel circuit.